Hi everyone, this video is an exercise 14C question 6. So this is an exponential modeling question, and in this question Nigel has bought a tractor for £20,000 and he wants to model the depreciation of the value of his tractor where t is in pounds and uh, small t is years. So his friend suggests two models. We have two equations basically. In part A, we want to use both models to predict the value of the tractor after 1 year. So t is in years, and when it says after 1 year, that just means when t is equal to 1. So for part A, we simply substitute the value of t is equal to 1 into both equations, and that basically is going to be the answer in this one. So for the first one, we have 20,000 e to the power of minus 0.24 times 1, which is just minus 0.24. And this is basically equal to 15 pounds of 15,723 pounds when we round this, obviously, because it's not exactly equal to this number. And for the next one, so we have 19,000 e to the power of minus 0.255 plus 1,000. And in this case, we have, and just to correct something, because for model 2, actually the answer is 15,723 pounds. But for model 1, when we substitute, we get 15,733 pounds. Right, so that's part A. Now in part B, we want to use both models to predict the value of the tractor after 10 years. So it's basically the same idea. The only difference is that we just substitute t is equal to 10 into both models. And for the first model, the answer is equal to 1,814 pounds. And for model B, we get 2,484 pounds. And so in terms of the comparisons, in part B, obviously, the second model gives a bigger value, which is interesting, and it's going to be, it might be, needed for part D, which is interpretation. However, in part A, we actually got very close answers. So that's interesting because the difference is that in part A, we are just predicting after 1 year, but in the second part, it's after 10 years. So in terms of the behavior, we can already assume that the way that the models are going to work is that in the beginning, they are very close in terms of the prediction. But as the time goes, then there will be some differences, noticeable differences. So for part C, we want to sketch a graph of t against little t for both models, basically. Right, so we just need to draw two exponential graphs. So model 1 has the equation 20,000 e to the minus 24t, and when t is equal to 0, we just get 20,000. So that's the y-intercept of the first model. So let's say here is 20,000. And then for the second model, we have 19,000 e to the minus 255t plus 1,000. So when t is equal to 0, we actually get 20,000 again. So that's the y-intercept of both models. Now, in terms of the first model, if we look at the behavior, so basically the main difference here is that we have minus 0.24t, but for the second model is minus 0.255t. So basically the rate of change of the second model is slightly larger, which means that the gradient is basically going to be a bit steeper for the second model. So you just need to be careful in terms of sketching that. So if here is the first model, let's say looks like this, then the second model roughly looks like this. It should be very close in the beginning, and then there will be some difference after some significant t. So this is model 2, and then the green one is model 1. Okay, so in part D, we just want to interpret the meaning of the 1000 in model 2 and suggest why this might make model 2 more realistic. Right, so when we look at model 1, basically what it's saying is just giving us, based on it purely depends on the value of t, and it just means that as t increases, then the value of car just keeps decreasing. So that's a very simple model, or in fact it might be too simple. But the difference is that model 2 has two components. So the first component is very similar to model 1, but the second component is this addition of this constant value of 1000. And there can be different interpretations. So one interpretation could be that we always have this 1000 pound value. For example, this could be the value of the tractors as scrap metal. So, you always have that value if you were to, uh, do something with your tractor, and whenever you just don't want it anymore. So that's one interpretation. You can simply say that this could be the value of a scrap metal, so that the tractor will always be worth at least 1000 pounds. That's the minimum, even if this value tends to zero still, because the idea is that when you think about model 1, this is mathematically going to tend to zero, right? So it just means that after so many years, the value of tractor is going to be zero pounds, or almost 0 pounds. Whereas the second model says that after many years, the value will be no less than 1000 pounds. So that's another interpretation.